So this is a video on trigonometry, and it's about double angle identities. So double angle identities, it's just basically the identities you get with trig functions when you double an angle size. So let me just draw a random right triangle. Yeah. Okay, I'll just create a random right triangle. So I'll put it at the right of the screen, and I'll add the border, and I'll remove the fill. Let me just duplicate it, and then I'll make the same right triangle again. So let's look at the right triangle at the top. So the right triangle at the top, let's say this angle here. Actually, let's say this angle here is theta. So this would be pi over 2 minus theta, because pi over 2 is 90 degrees, right? So pi over 2 radians minus theta. Now the bottom triangle is exactly the same as the top triangle. Like, that's just what we did. We just duplicated the triangle. So we know that firstly, if we assume that the hypotenuse is 1, so if we assume the side is 1, we know that we're using this triangle in a unit circle. Like, you can just draw out the unit circle here. Like that. And this point would be the center. And the circle would be something like this, right? And this is like the radius of the circle, so that's 1. So if this point is on the unit circle, it basically means that the x-coordinates of this point is cosine theta, or actually, yeah, cosine theta, and the y-coordinate is sine theta. Or actually, the x-coordinate is, well, negative cosine theta, and the y-coordinate is sine theta. Because we know that if this angle is theta, then the other angle is 180 minus theta. And using our properties, we know that cosine 180 minus theta is negative cosine theta. And sine 180 minus theta is just sine theta. So that's the coordinates for that point. What that means is that the length of this side is going to be, sine theta. Let me just draw this in black. So this is gonna be sine theta. Since the other triangle is like a reflection of the first triangle at the top across the x-axis, this length is also gonna be, so this length is also gonna be sine theta. So the entire side, the long side of this huge triangle here, is just 2 sine theta. And this is 2 theta. So we know the laws of sines, the law of sines, and there's 2 things, and also the law of cosines. So we can use those 2 to derive our 2 double angle identities. So firstly, let's just use the law of sines. By the law of sines, we know that 2 pi, so we know that sine 2 theta is over 2 sine theta, like this angle, sine of this angle over this side, equals, well, like, say, this side over, like, this angle, sine this angle over this side. So sine pi over 2 minus theta over 1, because that's just the side length of the hypotenuse over here. So the 1 basically just doesn't count as anything, right? And if we multiply both sides by 2 sine theta, we know that sine times 2 theta which is this is a double angle, it's double of theta, is gonna be 2 times sine theta times sine pi over 2 minus theta. Or we also know that pi over 2 minus theta, sine pi over 2 minus theta, is actually cosine theta. So this is just 2 sine theta. So this sine of a double angle, sine 2 theta, is equal to 2 times sine theta times cosine theta. So let's just box this identity then. That's the first double angle identity. Let's use the second double angle identity. Let's find the second double angle identity using the law of cosines. The law of cosines basically states that this side over here, which is 2 sine theta, so 2 sine theta squared, so we square this, equals the adjacent side, so this is 1, this is 1, so 1 squared plus 1 squared, so 1 squared plus 1 squared, so 1 squared plus 1 squared, minus 2 times 1 times 1 times cosine 2 theta. So that means that if we evaluate this is 4 times sine theta squared, and this is 2 minus 2 times cosine, the cosine of 2 theta. So we divide both sides by 2. We know that 2 sine squared theta equals 1 minus 1 times, so 1 minus cosine of 2 theta. So we want the double angle identity, so we want the double angle part on one side. So we add cosine 2 theta on both sides and subtract both sides from 2 sine theta squared. We have cosine 2 theta equals 1 minus 2 sine theta squared, which is the second identity.